we talked about that the angle sum of any polygon is 360, right? For the exterior angles. So I can add these up. It's 360. I can add these up. It equals 360. To find x, right? If we know these are all going to add up to 360, we'll just add them all up. Okay, so 2, 5, 11, 13, 18x. Negative 5 plus 10 is 5, minus 5 is 0. So it equals 360. So 20. So this one's going to be 40. This will be 100. Yeah, and then once you find the x, oh, I just found the value. Well, we'll just keep doing this anyway. 40 minus 5 is 35. 60 plus 10 is 70. And 120 minus 5 is 115.
Oh, wait.
If it's a regular nonagon, that's just when we use the formula. So it would be 360 divided by 9. So it would be 40 degrees. Okay, so a parallelogram is just a quadrilateral, so 4 sides, where the opposite pairs of sides are parallel. That's the definition of parallelogram. So squares and rectangles are also parallelograms, right?
Yeah.
Because their opposite sides are parallel. All right, so we have some properties of parallelograms. So we have, if a quadrilateral is a parallelogram, then its opposite sides are congruent. So if I have a parallelogram, that's not a parallelogram. That was a trapezoid. Parallelogram, opposite sides, congruent. Yeah.
What's it called when two lines reflect each other but they're not straight?
Like
an oval, two different sides of an oval.
symmetric. If a quadrilateral is a parallelogram, then the opposite angles are congruent. So this angle is congruent to this angle, and this angle is congruent to this angle. Okay. If we have a parallelogram, then consecutive angles are supplementary. So these two are congruent. These two are congruent. And then we end up with a situation again where the two different colors are going to add up to 180. Yes, it is. And then if a parallelogram has one right angle, it has 4 right angles, because if you think about that, I have a parallelogram. If this is 90, then this is 90, because they're congruent. Well, then these two add up to 180, so this has to be 90, and this has to be 90. So if one is 90, they're all 90, which makes it a rectangle or a square. So to indicate that sides are parallel, you do arrows going in the same direction on the side. So these two, this would indicate that that was parallel. And then I could do this to indicate that these two are parallel. Just in case you see that symbolism. All right, we have parallelogram AB, CD, and it doesn't matter what corner we start in, but once you start, you go clockwise to name it, okay? So I'm going to pretend that this is 55 degrees. This is 2.5 feet, and this is 1 foot. So how long is DC? Well, we have the opposite sides are congruent. DC is opposite AB. So it's 2.5 feet. Angle B is adjacent or consecutive. So that would make these two add up to, this one and this one will add up to 180. So 180 minus 55. So angle B is 125 degrees. And angle C is opposite, which makes it 55.
Looks a lot smaller.
So, well, yeah, it's just how I labeled it, but in actuality, these would be opposite, but we just labeled it, I didn't draw it to scale. Right.
So if you ask for the measurement of D, you would be over now.
Uh-huh. And this length here would be,
1 foot.
and then we have the 2.5 feet.
That's like straight.
Okay. The missing sides and angles, if this is 47, this is, which makes these two what?
Equal.
Yeah, but if this one's 47, what's this one?
123.
Perfect.
D.
So be smart.
123? 133.
No, no.
33. Close. If this is 32, this is, and this is
14.
okay. Anybody want to know why? Okay, if you're talking about a parallelogram, right? Oops, that's not gonna work. I'm gonna have to get rid of my shape. What I have is two parallel lines cut by a transversal. These angles are alternate interior, these are alternate interior. But I also have two parallel lines cut by transversals. Do you see that? So that's why we get those angles to be the same. And then the same lengths because they're parallel, so they're being cut off at the same amount of space. Does that make sense? Alright. Now, we've got some algebra to do. I was nice and I labeled these with color. The things that match. See how nice I was? So we can't find y yet until we find L. If this is 75, this is yes. So what I have is 5y equals 105. So y is 21. Well, not 21 degrees, just 21. Okay. X. I have 2x minus 1 and 75. Add 1 to both sides. 2x equals 76. Divide by 2. And x is 38. And then z. Z minus 4 is going to be 11. So add 4 to both sides. And z is going to be 15. And finally, we have w. W plus 4 is equal to 28, so you're going to subtract 4 from both sides. 3w equals 21. 24, thank you. So w is 8. So the parallelogram. We talked about diagonals with regular shapes, but we have special features of the diagonals. Oh, that's not right. Okay. If you have a parallelogram, your diagonals bisect one another. That means these two are the same length, and these two are the same length. Okay. Also, if we have a parallelogram, I should have made two of those, sorry. And we bisect it, or sorry, not bisect it, we draw a diagonal, and we draw another diagonal. Actually, we'll just do this. This is triangle 1 and triangle 2. So triangle 1 will be congruent to triangle 2. And if this is triangle 3 and this is triangle 4, those will be congruent. So if you cut the parallelogram on a diagonal, you get congruent triangles. And if you cut both diagonals, you get bisected, so congruent segments. This is not a theorem, but this is also true. These two triangles, congruent. These two triangles, congruent. Also not a theorem, but it's still true because we have vertical angles, right? So these angles will be the same as those angles. All right, what do I know about these two lengths here? They're this, yeah, they're congruent. So two, wrong color again.
Because even if like a line, you see it's like adjacent to something
Okay, these are congruent, so I'm going to subtract y from both sides to get that y alone. Y minus 5 equals 4. Add 4 to both sides, or sorry, add 5 to both sides. So y equals 9. Okay. What do I know about these opposite sides? They're the congruent. Now, they don't divide evenly, though, do they? That's okay. Because what's okay to have in math, even though you guys hate them? Fractions. So just leave it that way. Now, we didn't talk about this, but these angles are congruent, yes? Okay, like the whole thing. I have parallel lines, and my diagonal is acting like a transversal. So what do I know about these two if we're talking about parallel lines with a transversal? These will be alternate interior. So these will be the same. So 3z will be 33. So what's z? 11. Okay, so opposite big angles are the same, and then the opposite parts inside there are the same. Same on the other side. And then you've got vertical angles in the center, so those are congruent and add up to 180. The bisected diagonals make two congruent halves, and then your opposite sides are congruent. And then the corner angles add up to 180. And then the vertical angles in the center, the opposite ones add up to 180. See, and you thought you were doing math, but really it's just art.
These are opposite.
Look at these two, the y and the 28, those are the same, right? 2y and 28. Okay, so if 2y equals 28, what's y equal? Perfect. 7x plus 3 is equal to 4x minus 15, because they're the split diagonal. So you'll subtract 4x from both sides. That's plus 3, not minus 3. Subtract 3 from both sides. Negative 18. So x is equal to -6. And then you've got z's. Subtract z from both sides. 2z minus 4 equals 5. Add 4. 2z equals 9, and I know you hate them, but what's okay?
It's okay.
Fractions. Fractions are okay. 9/2. Alright, so what we do first, F, G, H, J. So you just kind of draw a parallelogram and go F, G, H, J, right? That way you know that a diagonal is going to be FH and JG. That's all you need to figure out to know what line you're looking at. And if the diagonals cut each other in half, what do you call the point that's in the middle of a line? Midpoint. And we know the midpoint formula, right?
It is.
Is this the easy way?
Yes.
And that formula is
I keep forgetting the slope formula.
We have to take it in the first.
Okay, so x1 plus x2. And now we can use FH or JG, it doesn't matter because they're going to meet at the same point, right? So I can use F and H or J and G. Which one do you guys want to use? J and G? Okay. So I'll have, this could be x1, y1, and this could be x2, y2. So I'm going to add the two x's together. So I get 3 plus -3, divide it by 2, and then 5 plus -4, divided by 2. So that's 0 over 2 and 1 over 2. So 0 and 1/2. That's the point. So all you have to use is the midpoint formula. You just draw the parallelogram and label it real quick so you know which line is the diagonal, which 2 points to use. Does that make sense?
At least it's in a
Yes. So if I have RSTU, I can quickly just draw a parallelogram. Oops, U. So I can either use R and T or U and S. Which one do you want to use?
US.
US. All right, go America.
How's it going to be undefined because there's a 0?
These aren't slopes, though. This is just a point. Yeah. If it was and it still wouldn't be undefined. It's only undefined if 0 is on the denominator. You can divide 0. 0 divided by any number is just 0. That's okay. You can't divide by 0.
Okay.
So 0 can be in the numerator. It just can't be in the denominator. So we're using U and S. So -6 plus 4. Divide it by 2. And then 7 plus -2. Divide that by 2. So that gives me -2 over 2 and 5 over 2. This is -1. And that's just 5/2. You can just leave it just like that. And so that's the point of intersection of the diagonals.